Okay, so to do the electrolysis of copper sulfate, we're going to use graphite electrodes. The question is, why graphite? There's two reasons. Number one, graphite, you should remember, is a giant covalent structure, macromolecular structure, and it contains carbon. And the carbon inside the graphite has 3 bonds. If I was to jig your memory with a little picture, then I would sketch you something that looks like this. This is graphite. Remember, it exists in layers, and graphite is a good conductor of electricity because within this, each carbon has 3 bonds. You know that carbon wants to make 4 bonds. Therefore, it's got delocalized electrons which can move through the structure, allowing it to conduct electricity. The second reason we use graphite is inert. Inert means unreactive. We don't want the electrodes to be part of this reaction, so we need them to be inert, unreactive. And there are 2 reasons why we have graphite electrodes. Okay, let's have a look then at what this means. Let me bring in a second sheet of paper for you. So here we've got our copper sulfate AQ, remember, means solution. Let's break this into the ions. So the fact that we have got copper sulfate as the ionic compound is going to give us copper ions, Cu2+, and sulfate ions, SO4, 2-. The fact we've got aqueous, remember aqueous means dissolved in water to make a solution, means we're going to get H+ ions from the water and OH- ions. Okay, so in this reaction for the electrolysis, we're going to deal with 4 ions as the electrolyte as part of this electrolysis process. So here's the diagram showing you the setup. Okay, so we have our DC power supply that we need to do electrolysis. We've got our anode and we've got our cathode. Remember, these are going to be made from graphite in this example, and they are sitting in the electrolyte, which is copper sulfate solution. And as we've just seen, that means it contains copper ions, sulfate ions, hydrogen ions, and the hydroxide ions. So cations are going to head towards the cathode. So these are going to start to migrate this way. Okay, let's just focus on those for a second. 2 of them get to the cathode. Now then, only one of those can react. And we need to remember the order in which they react. To do that, at the cathode, we bring in our reactivity series. And on the reactivity series, you can see that copper and hydrogen are here, meaning that hydrogen is the more reactive of the 2. Therefore, at the cathode, it's the least reactive that goes first, reacts first. So in this case, it is going to be the copper that is going to react first because it's the least reactive. So at the cathode, I will end up with my copper ions, Cu2+. What will they do? They will pick up 2 electrons to form copper. This is now gaining electrons, so this process here is an example of reduction. And what I would start to see happening is on the electrode, I would start to see copper metal starting to form on the surface of the graphite as this reaction proceeds. Let's go back to the anode. So the anode is going to attract the anions, that's the sulfate ion, and the hydroxide ion are going to go that way. When they get there, who is going to react first? Same question, different reason why. Here, the sulfate has got 1s, 4o, so it's got 5 parts to it based on that formula. The hydroxide ion only has 2 parts, 1O, 1H. It's got 2 parts. So at the anode, it's the simplest that's going to go first. So it's going to be my hydroxide ion. It's going to react first. Check out the other videos if you've forgotten how to work this out. You just need to get this into your memory banks, that repetition of this information. That's the equation. Notice my hydroxide ion is losing electrons. So this side is oxidation. And what I would see happening here, this electrode, is because we've got oxygen gas forming, I would start to see bubbles of gas forming at this electrode as the oxygen forms at the surface. Okay, hopefully that helps. Please watch that video as many times as you need to help you complete the notes and the activities in your book.